Hi, everybody. Today we are going to be reviewing intercepts and then talking about how those are related to zeros and factors for quadratics. So we know that a function is linear if it makes a straight line when graphed. So that is what we did during first semester. Here's an example. So if we have 2x plus 4y equal 8, nothing is squared, so we can assume that it is linear. If this were to be graphed, we can see that it has two intercepts. It has the x-intercept and it has your y-intercept. So x-intercept is on the x-axis, y-intercept is on the y-axis. What I like about these is that one of your coordinates is always 0. So for your x-coordinate, your y is always 0. And for your y-coordinate, your x-coordinate is always 0. So that makes it easy to find because all you have to do is substitute in 0. So if you want your x-intercept, make y 0. If you want your y-intercept, make x 0. You substitute it in and then solve for your variable. So those cancel out. You get 2x equals 8 divided by 2, and you get an x-intercept of 4. 0 makes things cross out, which makes it easier. 8 divided by 4 is 2. So y-intercept of 2. So let's say this wasn't graphed yet. You can just put your 2 dots on your graph and then draw a line and you'd be done. Not too bad. So how does that relate to quadratics or parabolas? As we know, quadratics are not linear. They are U-shaped. They have different parts, like the axis of symmetry, your vertex, your y-intercept, and sometimes your x-intercept. But the x, where it crosses the x-axis, that's called zeros. So that is a new word. Zeros are important because they are your answer or your solution. So if I ask you what is the solution to this quadratic, you're looking for the zeros. You can either have 1 0, 2 zeros, or no zeros. It's kind of like saying you have one answer, two answers, or no answers. So I'm going to show you what this would look like. So your zeros are where it crosses the x-axis. For this first example, it does not cross the x-axis at all. So there are no zeros. In this next one, it crosses the x-axis once. So my 0 here would be 2. So 2, 0. This next one, it crosses the x-axis twice. So we would say that it has 2 solutions. My 2 solutions would be at 1 and 3. Let's say you wanted to look at this example. It says find your zeros. Okay, so it's wherever it crosses the x-axis. So right here, where does it cross the x-axis? We would count it 1, 2, 3, 4, 5, 6, 7, 8. So that is negative 8. And then where does it cross it here? 1, 2, 3, 4. Negative 4. So this one has 2 zeros because it crosses the x-axis twice. These are called your solutions. You can find the solution to a quadratic by rewriting them in these forms. So if you want to find your solution either algebraically, so mathematically, you would just move the c to the other side, or you would put an equal sign in between ax squared plus bx. Normally it would say plus c, but instead now we have an equal sign. That'll help you find your solutions. And then, so that's standard form. You do the same thing for vertex form. Instead of plus k, it would be equals k, and you would solve for your x. If you wanted to graph these two different formats, you would graph the the first portion as a parabola, and then you would graph the second one as a horizontal line. Same thing, parabola, horizontal line, wherever your graph intersects, that would be your answer. So just as a quick sketch, let's say this was our parabola, this was our horizontal line, the points in which they intersect, whatever number that's at, let's say this is at 1 and then this is at 3, that would be your zeros. So I would have zeros at 1 and I would have zeros at 3. But that's only if you want to do them in this format. We're going to try this example. So it says draw a parabola. They give us our vertex and they give us our zeros. Okay, so the vertex is at 2, 4. So to the right 2, up 4. And then they give us our zeros. We know our zeros are going to be on the x-axis. So we have one of them at 0. And we have one of them at 4. And then it also says the axis of symmetry is, we know our axis of symmetry goes directly through the vertex. So it's going to go through 2. That's what's going to split our graph in half. So that is the line x equals 2. And then if we wanted to draw our parabola, we can see that it's going to open down. Oh, sorry. Ugly graph. Okay. So this one opens down. We have our vertex and we have our 2 zeros. So these would be your solutions. Okay. This, it says find for the given function. The function is written in, this one is in standard form. Find your axis of symmetry and your vertex. So you guys can try these ones if you want on your own time. This one says solve by graphing the related function. So this one, I think it's just having you make a table. So it's having you put it in the proper format and then make a table and then graph it. Again, just another practice problem if you want to try it. Let's see what this one looks like. By graphing the related function, so you would add 12 to both sides and then draw your parabola and then draw your horizontal line. And then where those two cross, that's your answer. You can try it if you want. Going. Oh, it's right here. Try this on your own. Same thing. This is a parabola. This one is a horizontal line. They're two different graphs. And then wherever they cross, that's your answer. More practice. This one, they want you to add 4 to both sides. But I want to show you something that I really love. So when I learned this, I was like, oh, duh, that makes sense. So hopefully this will make sense for you guys. This says graph the line y equals x plus 4 and graph the line y equals x minus 2 using the graphic calculator. I mean, I don't think you guys have graphing calculators, and you don't really need it for this one. Y equals mx plus b. Your b is your y intercept. Your m is your slope. So we're going to draw these two graphs, or these two lines. So the first one has a y-intercept of 4. Put a dot, pretty cool. This one has a slope of 1 because there's a 1 in front of that x, even if we don't see it. Up 1 over 1, put a dot, up 1 over 1, put a dot, up 1 over 1. And then backwards, up 1 over 1, up 1 over 1. Okay. We need a line. Oh, that didn't match. Let's try another one. There we go. Better. Not perfect, better. Okay. And then the next one has a y-intercept y-intercept of -2. Slope of 1, so up 1 over 1, up 1 over 1, again, again, and backwards, and backwards, and backwards. Okay, so graphing those two lines, pretty easy. It's what you guys learned last year. We did a little bit of it this year too. If I looked here, the next part it says, what are the x-intercepts of these two lines? Okay, well, it crosses here and here. So what are those two numbers? We have -4 and we have 2. Counting by 2s. 2, 4, -4. Okay, so like if the problem just said, hey, I want you to figure out the intercepts, you would be done. So that's one method. Another method is saying, okay, we have the same problem, but hey, let's look at it in standard form. So I'm going to show you how they turn it into standard form. They take these two lines and they multiply them as a binomial. So they do x plus 4 and they multiply that with x minus 2. I'm going to do the box method because I think it's more organized. You can do whichever method you want. X times x, x squared, x times 4, 4x, -2 times x, -2x, and then 4 and -2. Combine the middle, they are like terms. Okay, those ones are like terms. Okay, so now it's going to say, take this and we are going to graph this one. Okay, sure, whatever. Let's start with a equals 1 because it's in standard form, b equals 2, c equals -8. Let's start with the easy one. We know our y-intercept is 0, comma c, and then our c here is -8. So we can say our y-intercept is 0, comma -8. All right, cool. We got 1 point there. We also need our axis of symmetry. So to find the axis of symmetry, we do -b divided by 2a. Okay, so we got negative and then b. Our b is 2 divided by 2 times a. A is 1. All right, we get -2 at the top. We get normal positive 2 on the bottom. And that equals -1. All right, cool. Let's start putting this on our graph. We have a y-intercept of -8, so there's a dot there. There's going to be a dotted line through 1, -1. So dotted line. Okay, now let's find our vertex. To do our vertex, we need to use our axis of symmetry. So this number that we got for x, we have to put that into our original equation. Our original equation is x squared plus 2x minus 8. And then we're just going to put a -1 anywhere we see an x. Okay, -1 times -1 is +1, -2, -8. Put my negatives together, -9. All right, so my vertex is my x and my y. My x was -1, which we got up at the top. My y is down at the bottom, -9. Okay, now we can put this on our graph. -1, -9, -1, -9. We can also put an additional point on the left side. since we know that it's symmetrical across the axis of symmetry. And then this is the amazing part, guys. Wow, look at that. Wow, look at how cool. So if you don't know what I'm talking about, these orange dots right there, they're also on your graph. They are the same zeros because they are the same two lines. So those two purple lines that we just graphed, they give you the same zeros as you would get if you were to graph the parabola. Why is that important? It's important because you have options. So option 1 is the purple, which took us like no time, or option 2 is all of this stuff on the right-hand side. If you had the choice, which option would you choose? Option 1 or option 2? I mean, I would choose option 1, honestly, because it's a lot less work. So what that is called factoring. Okay, so that is taking something that is in standard form and you are changing it to look like this. These are factors. These are in factored form. Once they are in factored form, it's so much easier to find your zeros because you can just set them equal to 0. So like if I wanted to solve this one, I'd be like, oh, no problem. X plus 4 equals 0. And then x minus 2 equals 0. We're finding our 0, so we're going to set it equal to 0. Oh, no problem. Bam. There's one of my zeros. Bam. There's my other 0. And oh, what do you know? Same thing that we got here. And same thing we get on our graph. That's the nice thing about math is there's all kinds of different ways to do it. It's just figuring out the most effective way. So this is the beginning of your factoring math life. It's only going to get much more exciting. I hope you guys are ready to learn because this is going to be the push for the end of the year. I don't get to see you guys in person, but I still want to be here to help you guys learn because it is really important for when you guys go to high school. So stick with me. If you have questions, please email me. If you guys want to do like a separate Algebra 1 WebEx meeting where we can just talk about everything that's confusing, we can do that. Just let me know what you guys need from me, and I will do everything that I can.